Hi, I'm Vanilla. In today's video, I would love to explain Kirchhoff's voltage law with a simple analogy. Imagine you are out for a mountain hike. You start by hopping on a chairlift that takes you 100 feet straight up a ridge. From there, it's all downhill back to your starting point. First, you scramble down a rocky slope for 60 feet. Then you pass through a muddy patch that is less steep, but still you drop another 40 feet. Finally, you take one last step, only to end up exactly where you started. If you climb up 100 feet and end up back at your starting point, then you must have walked down 100 feet at some point. After all, you can't finish your walk hanging in midair. Think of voltage as elevation, and the hiking path represents the circuit loop. When you use a chairlift or climb up a ridge, your elevation increases. This is like a battery adding voltage to the circuit. As you hike down different trails, your elevation decreases. These descents are components like resistors that drop voltage. If you finish your hike exactly where you started, your net change in elevation is zero, regardless of how many peaks you climbed or valleys you crossed. Similarly, in a circuit, no matter how many batteries or resistors you encounter, the sum of all voltages in a closed loop always equals zero. This is exactly what KVL is all about. Kirchhoff's voltage law states that the algebraic sum of all branch voltages around any closed loop of a network is zero at all instants of time. KVL represents the law of conservation of energy. To solve any circuits using KVL without getting confused, follow these 5 steps. First, you have to identify the loop. A loop is something similar to the path you take on a mountain hike. It starts and ends at the same point. In simple terms, a loop is any closed path. In an electrical circuit, a loop is any simple closed path that starts and ends at the same node. Look at this circuit. Here, the nodes D, A, B, D form one loop. D, B, C, D is another loop. A, B, C, D, A is another loop. Totally, in this circuit, we have 3 loops. After identifying the loops, we have to pick a direction. We can either use clockwise or anti-clockwise direction. It doesn't matter. Normally, people always choose the clockwise direction to avoid any confusion during problem solving. The next important step is to label the polarities. We need to identify the positive and negative terminal for every component. This part can be tricky, so you must be very careful. There are 2 types of components to label, the source and the passive elements. This labeling depends on the direction of the loop current you have chosen. The source polarity is fixed and does not change with your current direction. The long line represents the positive terminal and the short line indicates the negative terminal. For passive elements, the polarity depends entirely on the assumed direction of the loop current. Mark the side where the current enters the resistor as positive and the side where it leaves as negative. Our 4th step is to write the KVL equation. According to KVL, the sum of all voltages in a closed loop is 0. Let's consider the voltage across 20 ohm resistor BV1 and the voltage across the 30 ohm resistor BV2. In this circuit, each component has 2 signs, the starting sign and the ending sign. While writing the KVL equation, you must follow either the starting sign or the ending sign. I usually follow the ending sign. Therefore, plus 15 minus V1 minus V2 plus 10 is equal to 0. This is the KVL equation for this circuit. Now let's move on to our final step. The final step is to solve the equation. Let's consider the loop current as I. According to Ohm's law, V is equal to IR. The current flowing through the 20 ohm resistor is I. So the voltage across the 20 ohm resistor is V1 is equal to I into 20. Therefore, V1 is equal to 20I. Similarly, V2 is equal to I into 30. V2 is equal to 30I. Substituting V1 and V2 into our equation, we get 15 minus 20I minus 30I plus 10 is equal to 0. Simplifying, 25 minus 50I is 0. From this, I is equal to 0.5 amps. The loop current is 0.5 amps. If you have any doubts, let me know in the comment section below. Now look at this circuit. Here we have one loop. As usual, we will follow the clockwise direction. As for us labeling the polarities, we can skip that step because the polarities are already labeled. Don't ever get tempted to change the polarities if they are already marked in the question. Now, let's write the KVL equation for this circuit. Minus 9 plus 2 minus V1 equal to 0. From this, V1 is equal to minus 7 volt. That's all for today. Bye. See you in my next video.